For this podcast, please have note page number 9 in front of you. We're going to talk about specifically unsaturated aliphatics. We're going to spend this podcast talking about the alkenes. Now, the simple fact that we're dealing with alkenes, we know that we're going to have a double bond located within our organic structure. The formula that you're going to be using for the alkenes is going to be CnH2n. Basically, you're always going to have twice as many hydrogens as carbons within the formula. We're going to end with an ENE. N-alkene is the N tells you what carbon number the double bond is located at within the molecule, so we're going to use N only if we have more than 3 carbons present. All right, for example, if we're dealing with propene, we're going to use prop, which is going to represent, obviously, the 3 carbons. So N is going to equal 3. We're going to go ahead and use our formula of CnH2n. You're going to plug a 3 in for each of the N's. And our final formula is going to be C3H6. All right, here's an example of the propene. Number our carbons, 1, 2, 3. You can see the location of the double bond present between the first and the second carbon. So we can name this 1 propene. Right? The 1 represents the location of where the double bond is, but since 1 is the only location where the double bond can be present here, it's not necessary to put in the number 1. If you have more than 3 carbons, then yes, it's going to be necessary to have the location of where the double bond is. All right. Now we're going to talk about some straight-chained alkenes, and then we'll get into some branched alkenes as well. Straight-chained alkenes first. Number the lowest number carbon where the double bond will be located. Then add the prefix ENE at the end. It's that simple. So if we take a look at our first example here, we can see that we have 1, 2, 3, 4, 5 carbon atoms. If we're going to number, so the location of the double bond is at the least numbered position. Let's see, if we go this way, we get 1, 2, 3, 4, 5. If we go in the opposite direction, you get 1, 2, 3, 4, 5. So going in this direction is going to give us the location of the double bond at the lowest possible value. So to name this particular straight-chained alkene, the location of the double bond comes right after the carbon that it sits on. We've got 2, and because we have 5 carbons, pent is the prefix for 5, and because we're dealing with alkenes, we finish with an ENE. All right, the next example, you have a couple double bonds here. Let's go ahead and identify where the carbon atoms are first. All right, here's 5 of them again. So we know we're going to be dealing with pent one more time. If we take a look at the location of where the double bonds are, we've got 1 here. We've got 1 there. All right, we're going to number in this direction. 1, 2, 3, 4, and 5. If we go in the other direction, we're going to have our first double bond located on the 2 and then also on the 4 as far as the carbon atoms go. So if we go in this direction, we've got the double bonds located at the 1 and the 3. All right, this is definitely going to provide for us the lowest sum number of double bond locations. So if we're going to go ahead and identify what type of compound this is, we're going to start with numbering where the double bonds are, 1 and 3. We're going to go to the pent, because we know we're dealing with 5 carbons. And we're going to finish off the end of this with ENE. Now, something that's different. We have 2 double bonds here. Prefix for 2 is di. So 1,3-pentadiene. A little reference to a cartoon here. You can see the 2 double bonds here. To make light of the whole situation, it says, help me, I'm dying, which means it has 2 double bonds. A little chemistry humor there for you. All right, the next problem, this one's going to be related to the branched alkenes. All right, so no longer straight prefixes. We're going to get into the branched alkenes. All right, definition says, branch prefix comes first. So our branch is going to come first within the name. The parent chain comes last in the name, along with the number of where the double bond is located. All right, so our longest possible chain is going from 1, 2, 3, 4. So simply going from left to right. Here's the location of our double bond. That's important when it comes to our naming. Here are our 2 branches, 2 methyl groups being branched off of number 2 and number 3. So the first thing we do is identify where those branches are. So we've got 2, 3. We have 2 methyl groups, so dimethyl. And then finally we locate where the double bond is. The double bond here is located at number 4 if we went in this direction. So we want to flip-flop our numbers here and number this way. Whoop, sorry. I'm going to go ahead and number this way. 1, 2, 3, 4. Now the location of the 2 methyl groups is still going to be 2, 3, but in going in this direction, you can see that we're going to provide the lowest possible location of where that double bond is. And that's going to be off of carbon number 1. So we're going to finish this off with 1. And we have 4 carbons present, so we're going with bute. And then we finish up with the suffix of ene because we are dealing with the alkenes.